I am Mongol Gandhi, working as Assistant Professor in the Department of Computer Science and Engineering in Vignan's Foundation for Science, Technology and Research. Currently, I am pursuing my PhD in JNTU Kakinada. My research areas are data mining, machine learning and deep learning. In this semester, I am going to deal the subject of search engines. Search engines. This is one of the familiar word we are regularly using in our life, and we are very popular with some of the words like Google, as we are very familiar with this word Google in our regular lives. For what purpose we are using the Google here? So Google is one of the popular search engine in current days. We are regularly working with the Google from the morning wake up to the going to the bed. If you want to get any information or if you want to retrieve any information on the World Wide Web. As part of this one, in today's class I am going to introduce the course description. Course description. This course deals with the technologies, various methods used in finding relevant information on the web. So there are different technologies, various methods we are going to use for finding relevant information on the web. And next one is course objective. The objective of this course is to understand the existing techniques of the search engine and use the mathematical models to build a fair search engine. So we are going to use different existing search engines and use the mathematical models to build a fair search engine. Next, course outcomes. After completion of this course, the student should be able to understand and outline the search engine architecture and analyze how does it really work. CO1 is outline the search engine architecture and analyze how does it really work. CO2, summarize to crawl the web and apply different text processing techniques. So we are going to know about the crawling and how to crawl the web. We are going to know about as part of the CO2. CO3, experiment with indexing concepts and identify query transformation and refinement techniques. CO4, develop retrieval models and evaluate search engines. So these are the four outcomes should be reached by all the students after successful completion of this course. So as we are already familiar that as part of our subject we are having the 5 units. The first unit is going to cover what is the search engine, who is the search engineer, and architecture of the search engine, what are the basic building blocks and breaking it, and how does it really work. So as part of the unit 1 we are going to learn introduction for the search engines, and we are going to know what is the basic building blocks, and we are going to familiar with the architecture of the search engine. Unit 2 is going to cover crawls and feeds. So as part of the crawls and the feeds we are going to know how to crawl the web and how to store the documents, and among all the documents how we are going to identify the duplicate documents. And as part of the second part of the second unit we are going to know that how to process the query, how to process the query of text. So processing text from words to terms. So with that we are going to know that text statistics, document parsing and structure and markup, link analysis. As part of the link analysis we are going to understand one of the familiar and popular algorithm, page ranking algorithm. So that was proposed by Google founders Larry Page and the Sergey Brin. So this is about the unit 2, and unit 3 is going to cover about the introduction for the indexing and importance of the indexing and its significance, and we are going to know about compression techniques and inverted index and how to create primary index, secondary and ternary index construction. And as part of the unit 4 we are going to know what is a query and interfaces, queries and the interfaces. As part of this one we are going to know about what is the need of the information, what are the different query transformation and refinement techniques, and what are the different retrieval models, probabilistic models, and ranking based on languages and application based models. Unit 5. In the Unit 5 we are going to cover search engine evaluation, why evaluate, the evaluation, logging, effectiveness, metrics, efficiency, testing and statistics. So if you want to know the performance of the search engine, one can evaluate the search engine. Then we can come to know how effectively and how efficiently the search engine is going to work. We are going to know about this one in the as part of Unit 5. So in today's class, I am going to start Unit 1. We are going to cover, these are the contents of the Unit 1 we are going to cover in this class. What is a search engine? Who is a search engineer? Goals of the search engine, basic search engine architecture, basic building blocks. What is a search engine? What is search engine? Just think of it. Now I am going to give the brief explanation about the search engine. If you observe here, there are a number of words: Google, Yahoo, Ask, AOI.com, DuckDuckGo, Bing, Baidu and Wapom Alpha. They are the different words in our regular lives we are using. Among all these words, one of the most popular word is about Google. So Google here is going to play an important role as part of in our regular lives. Now I am going to explain the theoretical definition for the search engine here. A search engine is the practical application of the information retrieval techniques to large text collections. So here the search engine is the practical application for the information retrieval techniques to the large text collections. As we already familiar that a web consisting of huge collection of the web pages, and in the web pages there are number of PDF documents, Word documents, XML documents, HTML, number of documents are available. Among all those documents, whenever a user has whenever the user is trying to retrieve any particular information on the web, so that's what he can enter the web search query. We can simply call it as a web search query. Whenever he enters, he is able to retrieve ranked list of documents. So here, how we are just defining the search engine. The search engine is the practical application of the information retrieval techniques to the large text collection. Here, web search engine is the one of the obvious example. Web search engine is the one of the example. So how we can define the web search engine? Web search engine, we can simply call it as internet search engine also. Web search engine is also known as the internet search engine. We are simply defining it as it's a software system or online tool. It's a software system or the online tool that is designed to carry out web search. That is designed to carry out the web search. We can simply call it as a internet search, which means to search the World Wide Web in a systematic way. As I already told you that a web consisting of huge collection of the documents, among all the documents, whenever you want to find relevant information on the web, so you are going to search for any one of the particular information, obviously you are able to retrieve. For example, if you want to find information about Mahatma Gandhi, so what you can do generally, you simply open your Google, www.google.com. You are able to find one user interface. In that user interface, you are having Google button is there, and you will be having one text box. Under that, two buttons are there. You enter Mahatma Gandhi or autobiography of the Mahatma Gandhi. Then you hit on the search button. Whenever you hit on the search button, you are able to retrieve the information about the Mahatma Gandhi as a ranked list of documents. So this is one of the best example for the web search engine. So whenever you try to understand here, this is the user interface of the Google. Whenever you want to retrieve any particular information on the Google, you can simply go and type the text here. You are able to retrieve the information as part of the ranked list of documents. So here this is the result pages you are going to retrieve whenever you search the web. So search results are generally presented in a line of results. We can simply call them as the SERPs. We can simply call it as search engine result pages. We can call them as the search engine result pages. The information, it may be the mix of different links to the web pages, images, videos, infographics, articles, research papers, and other types of the files. And whenever you search any information on the web, you are able to retrieve the ranked list of documents. So a few of the examples what I already told you about Google and Yahoo. Google and Yahoo. So what they can do is they must be able to capture or crawl many terabytes of data. They are going to crawl many terabytes of the data. So here, whenever you search on the Google and you are eagerly waiting that why the Google is not giving immediate response and what is the related information I want. So when you can think of it, there are terabytes of data. So in a way of different text collections, huge collection of the documents are available in the web. Among all the documents, one can need to identify the related documents for that web search query. Then only it is going to give the response. So here if you observe, the then provides subsequent response times to millions of the queries submitted by every day from around the world. So this is as part of Google and Yahoo, we are regularly familiar. So this is the spider. You are able to understand that what the spider can do simply. So it can crawl. So that's what whenever you observe the web, so there are different nodes. So we can simply call them as there are different documents are available. Whenever you will be having the different documents, so we can simply assume them all the documents as the nodes. So whenever you want to move here, you can observe the crawler is able to identify in a clear way what the crawler is going to do. It is going to crawl or navigate to the different places. Whenever you see the web consisting of different documents, and there are a huge collection of the documents are available. Whenever the web search query has entered by any one of the user, the Google, what it can do, the crawler will take the responsibility and it will crawl, and it is going to identify the related documents. That is the responsibility of the crawler. So here the next one is search engineer. Who is a search engineer? The people who are having the knowledge in the computer sciences and having the knowledge in the databases. They are the main people behind the search engines. So search engineers are the primarily people trained in computer science, mostly with the systems or the databases background. The people who are having the knowledge in computer science and mostly having the knowledge with the systems or the databases background. So here, what is the responsibility of the search engineer? What is the responsibility of the search engineer? The main responsibilities are, if you try to understand, so designing and implementing new search engines. They are the main responsibilities of the search engineers. Designing and implementing new search engines, and they can also extend the services, like they can modify, they can extend, they can optimize, they can maintain or tune existing search engines for the wide range of commercial applications. So they are also having the ability to extend the services by extending and by optimizing, maintaining and tuning the existing search engines. So these are the primary responsibilities. They are designing and implementing new search engines. Next one, goals of search engine. What are the goals of the search engine? Just try to imagine what you can expect from the search engine. With that, we can simply try to understand these are the goals of the search engine. So, two primary goals of the search engine. There are mainly two primary goals of the search engine. One is effectiveness and the second one is efficiency. The first one is the effectiveness and the second one is the efficiency. Effectiveness is always deals with the quality of the information. Efficiency will always deals with how quickly you are able to retrieve the information. This is what about effectiveness. Effectiveness, quality, efficiency, speed. So we will try to elaborate what is effectiveness. We want to be able to retrieve the most relevant set of documents possible for a query. Whenever you enter the query, you are able to retrieve all the most possible queries, all the most possible answers for that query. So in a qualitative way, this indicates the effectiveness. And efficiency. We want to process queries from the users as quickly as possible. So whenever you enter the web search query, you are able to retrieve as fast as possible. For example, you are in a hurry that you want to retrieve one particular program, so that's what we can simply call it as you want to write a program for finding Pascal triangle program. For that, you are able to search in the Google search, then you are able to retrieve number of documents are there. So immediately you will be having some of the links, link 1, link 2, link 3, link 4, like that. So you are able to find the first link is maybe the appropriate one for your answer. Then what you can do is you just choose the first link. Now we are going to discuss about search engine architecture. This is one of the very important concepts we are going to learn as part of the search engines in the first unit. So there is no universal agreement on the search engine architecture, but as part of different search engine applications, we are going to see this architecture as building blocks. As part of the building blocks, we are going to see a few of the components and it's breaking it down. Now we will see a software architecture. A software architecture consists of software components. So it consisting of the software components, the interfaces provided by them, the interfaces provided by those components. Now you try to understand in a generalized way the software architecture majorly consisting of the software components and the interfaces provided by those components and relationships among them, relationships between them. Now what the software architecture generally going to give as it describes a system at particular level of abstraction. It gives the system at the particular level of abstraction. And as part of this architecture, we are going to determine two requirements. We are going to determine the two requirements. In the previous slide, we discussed that the goals of the search engine are effectiveness and efficiency. So effectiveness, I told you that it deals with the quality, and efficiency deals with how quickly it is able to retrieve the results. So that's what speed and quality. So here effectiveness and another one is the efficiency. Effectiveness and efficiency. So quality and response time. And you will be having throughput. What is throughput? The number of queries processed per second. This is what throughput we can simply call it as. So there is no universal agreement on the software search engine architecture, but as part of the software architecture, we are going to see that provides software components and interfaces and relationships among those components. So this is about the basic information, and it is going to give the system at particular level of abstraction. And the search engine determined by two requirements. The architecture of the search engine determined by two requirements. One is effectiveness and another one is the efficiency. So this is what I just discussed about. We want high quality results. We want high quality results. The search engines carefully process the text and store statistics that help improve the relevance of the results. It is going to take the support of the statistics of the text, and accordingly it is going to give the relevant results, relevance of the results. So that gives the quality. That gives the quality. And next one, if you want an efficient system, search engine employ specialized data structures. It is going to employ the specialized data structures, and they are optimized for fast retrieval. So we are going to introduce the specialized data structures like inverted index for processing the text, and if you want to process those indexes in an efficient manner, you are going for the optimization of those structures. So this is about the part of architecture part. And next, we are going to understand the entire architecture as the building blocks. As if you observe the basic building blocks, search engine components support two major functions. It is supporting two major functions. One is the indexing process and another one is the query process. Indexing process and second one is the query process. The indexing process builds the structure that enables searching. So as part of the indexing process, it is going to generate the index. So here it builds the structures that enable the searching. Next, query process. The query process is going to use the structures and person's query to produce a ranked list of documents. The query process uses those structures in the sense the structures provided by the indexing process, and person's query is going to use the person's query to produce ranked list of documents. So there are two major basic building blocks. One is indexing process and second one is the query process. As part of the indexing process, one can build the structures, and as part of the query process uses those structures, the structures provided by the indexing process and person's query to produce ranked list of documents. So this is about basic building blocks. Now we will try to understand the two basic building blocks in detail. So the indexing process consisting of majorly three components. One is text acquisition, and second one is text transformation, and the third one is index creation. They are the three main components of the indexing process. Along with that, we are able to find some more words in this diagram. So this is email, web pages, news articles, memos and letters. So, and this is what we can try to understand the entire web. Web is a world wide web consisting of a huge number of documents. And here you will be having the document data store. It is a database. We can simply understand. So it consisting of different documents and its metadata. So document data store. Finally, you are going to create the index. So indexing process mainly consisting of text acquisition, text transformation and index creation. In the next slide, we are going to understand what the indexing process can do as part of three components. So these three components will try to understand in a clear manner what the text acquisition will do. So acquisition, text acquisition. I will try to explain this one with one generalized example. For example, whenever you want to retrieve any particular information on Google, you just open www.google.com. Very good. Then what you can do, you can enter the web search query. Whatever the information you want to retrieve. At the time after entering, so it is going to be processed. So for the web search query, what you entered, it is going to search all the documents available on the web. So here acquisition. So as part of the acquisition, one can try to understand, it is going to identify the documents. So here as part of text acquisition, it identifies and stores documents for the indexing. It identifies and stores the documents for the indexing. Whatever the web search query you entered, for that query, all the documents are identified and those documents are stored for the indexing. So here, as part of the text acquisition, one can identify and stores the documents for the indexing process. So that is the responsibility of the text acquisition. Next, text transformation. As part of the text transformation, the word having meaning, transform one to another. So here, whatever the documents identified in the text acquisition phase, all the documents are stored all the documents consisting of a lot of textual information. That entire text present in the documents are going to be converted so as index terms. So here, which transforms the documents into the index terms or features. The features is the general word we are familiarly using in the word in the area of the machine learning. So which is going to transform all the textual information into the index terms or the features. The third component is the index creation. So here, index creation. So index creation is going to take the input from the text transformation phase, and it is going to use all the index terms, and it is going to build the structures, data structures. That's what indexes, which supports for the searching. So these are the three main components of the indexing process. One is text acquisition. So text acquisition is going to identify and stores the documents for the indexing. Next, text transformation. So text transformation, all the textual documents information is going to be converted into the index terms or the features. And the third one is index creation. It takes the input from the text transformation phase, and it is going to convert or create the data structures. We can call them as the indexes, which is used for the fast searching. So here, among all the documents, one can search, and they are all identified in the text acquisition phase, and they will be transformed into the index terms or the features, and finally index is created. Finally index will be constructed. Here you will be having document data store. It is having huge collection of the documents, so it consisting of metadata and data. You will try to understand here, the task of text acquisition component is to identify and make available the documents that will be searched. Make available the documents that will be searched. So here, text acquisition will often more require building collection by crawling or scanning the web. So I already explained you by showing the spider diagram in the previous slides. So the spider, what it can do, it can crawl throughout the web, otherwise it can scan. We can also call the crawler or crawling with another name spider or the boats. Crawler, we can also call it as spider or boats. So crawling or scanning the web. In addition to passing the documents to the next component, indexing process, as part of the indexing process, the text acquisition component creates the document data store. Document data store. It can also create the document data store. So the document data store consisting of consisting of text and metadata for all the documents. It consisting of text and metadata for all the documents. So here, what is metadata? Metadata is the information. So we can simply call it as it's a data about the data. So it is about a document that is not part of the text content, such as the document type. For example, email or web page. So this is about the text acquisition phase. And next we will discuss about the text transformation in detail. As part of the text transformation component, so what we are going to understand, it is going to be transformed into the index terms or the features. Index terms or the features. So index term, as the name implies, they are the parts of the documents that are stored in the index. That are stored in the index and used in the searching. So the index terms, as the name implies, are the parts of the document. They are all the parts of the index terms, as the name implies, are the parts of the documents that are stored in the index and used in the searching. So it is going to identify the index terms and they will be used in the searching. So here you will be able to find one new word, index vocabulary. So what is index vocabulary? The set of all the terms that are indexed for the document collection. That are indexed for the document collection. We can call them as the index vocabulary. So this is about the text transformation phase. And the third component is index creation. And the third component is the index creation. The index creation component takes the output of the text transformation. So it takes the information or the information from the text transformation phase. So and it creates the indexes or the data structures that enable fast searching, that enables the fast searching. Here, given a larger number of documents in many search applications, index creation must be efficient both in the terms of time and space. That must be efficient in the terms of time and the space. Indexes must also be able to efficiently updated when new documents are required. This is the one of the very challenging tasks. If you try to understand in your web, a number of documents are adding in day-to-day life. So for example, if I am maintaining my website, that website I am maintaining one particular subject about the search engines course. Whenever I found any new information about it, I updated in my website. Whatever the new information I updated, that need to be reflected. Those documents will be added to the web. So when new documents are required, inverted index or sometimes inverted files are by far the most common form of the index used by the search engines. So inverted files. So this is about the index creation. So these are the three major components of the indexing process: text acquisition, text transformation, and the index creation. Next, we are going to know about query process. So if you see the diagram, you are able to find three more components. They are user interaction and ranking and evaluation. I already told you, as part of the query process, it is using the structures given by the indexing process and user's query. With that, it is going to generate ranked list of documents. So here, if you try to understand, so this here the person, what he is doing, he wants to find any one of the particular information. You just imagine you are before the Google. You want to find one particular information about for example, Mahatma Gandhi. So you want to type about Mahatma Gandhi. So whenever you enter, so here there is a user interaction. So here user interface, it is acts as a medium between system and the user, and so one more component you are having, ranking. It is the one of the important of entire query processing. So it is the core of indexing process, core of query process. Next, the third component is the evaluation. So if you want to know the performance of the search engine, one can need to monitor and measure the effectiveness and efficiency metrics. Then accordingly we are able to evaluate the search engine. Then here log data, it's about how the users are interacting and total information click through. So different sort of information will be maintained in the log data. And we will see each and every component in detail when you try to understand each and every component of query process. So user interaction, what the user interaction here is going to provide. So it supports creation and refinement of query, display results. So this is the user interface. For example, whenever the person before the Google, what he can do, he can provide the web search query to the Google, then that query will be processed, then it is going to generate the different results. All the results will be displayed on the screen. So that's what it is going to generate the results, and it is going to do the ranked list of documents, which supports and the refinement of query. So whatever the query you entered, that will be transformed. The query will be transformed and that will be processed, and related documents for the query will be identified and they will be generated as results. And another component is the ranking. What the ranking is indicating, so I told you which uses the queries, uses the query and indexes, to generate ranked list of documents. It is going to use the query and indexes to generate a ranked list of documents. And the third one is the evaluation, which monitors and measures effectiveness and efficiency. So it is primarily offline. Now we will see the in detail about user interaction phase. So the user interaction component provides us. So we are going to discuss about the user interaction. The user interaction component provides the interface between the person doing the search and search engine. So here, whenever you before the Google is the medium between the user and the system. So that's what we can simply call it user interaction. And one task of this component is, what is the main task? Accepting the user's query. It takes the user's query and transforms into the index terms, and it is going to convert into the index terms. Another task, there is one more task for this, to take the ranked list of documents from the search engine and organize it into the results shown to the user. So it acts the user's request and it processes it, and it is again going to display the results from the search engine side. So finally the user can find the different ranked list of documents. And for example, generating snippets used to summarize the document content. So browsable summary. So whenever you generate ranked list of documents, so a snippet, so that gives the entire description about the documents. The document data store is one of the source of the information used in generating the results. Finally, this component also provides a range of techniques for refining the query so that it better represents the information need. So whenever it is need for a particular thing, so that gives what the particular need of it. So that represents right. And the next component is ranking. The ranking component is the core component of the search engine. It is one of the main core component of the search engine. It takes the transformer query from the user interaction component and generate ranked list of documents using scores based on a retrieval model. Now I will give a small example. One of the popular algorithm proposed by the Google founders Larry Page and Sergey Brin is page ranking algorithm. So that is one of the popular algorithm used by the Google. Whenever you want to search any particular information on the web, so that plays an important role in displaying the ranked list of documents. For example, today I search one particular information about Mahatma Gandhi Garu. Then I am able to list out some of the links in this particular day. After 10 days, whenever search about Mahatma Gandhi Garu, then I am able to retrieve some number of links. Now we will compare. So whatever the list of documents you retrieved on the particular day and today. So if you compare both of them, there may be the chance for having the same links on the same order, and the order may be changed. Why? The number of viewers visiting the particular links, if increases, the rank of the page will be increased. The pages which are having the more rank, they will be displayed on the top. So that's in that way the page ranking algorithm will work. Like that, there are a number of algorithms are working, but one of the popular algorithm is the page rank. Retrieval model. So that is one of the mathematical model that is the basis for the ranking. So ranking must be both efficient, since many queries may need to process in short time and effective. In the short time and effective, if you want to process, so that need to be efficient. Since the quality of the ranking determines whether the search engine accomplishes the goal of finding the relevant information or not. So this is about the ranking component, and the last component is the evaluation. So evaluation. The task of evaluation component is to measure and monitor and efficiency. So the task of evaluation component is measure effectiveness and efficiency. So with this we can come to know the performance of the search engine. There are two words or two measures, precision and the recall. We are going to know about it, and by that we are going to evaluate the search engine. An important part of this is to record, analyze the user behavior using the log data. So here in the log data, we'll be having the total information. With that, we can analyze. So analyze the behavior of user. Analyze the behavior of the user. So the results of evaluation are used to tune and improve the ranking component. Those results will be used to tune and improve the ranking component also. So these are all the total components of the query process: user interaction, ranking, and evaluation. Finally, I would like to conclude this session by briefing about entire today's class in a few minutes. So in today's class, we discussed about the course description, course objective, and course outcomes. Then after, we have seen what are the different units present in the entire search engine subject, what are the different units consisting of, and what we are going to study. As part of the unit 1, we covered few of the topics like search engine, what is a search engine, what are the different practical applications of the search engine, who is a search engineer, what are the responsibilities of the search engineer, what are the goals of the search engine, and what is the architecture of the search engine, and what are the basic building blocks. As part of the basic building blocks, we covered two building blocks. One is the indexing process and second one is the query process. As part of the indexing process, we covered text acquisition, text transformation, and index creation. As part of the query process, we covered user interaction, ranking, and evaluation. With this, I am concluding this session. Thank you one and all.